To finish off lesson 2.1, we want to take a look at another scatter plot. This one is in regards to salmon population in the Pacific Northwest, and it's been collected over, looks like about a range of 40 years from 1960, well 30 years, 1960 up to 1990. Now, we don't want to use the years, we want to use years since 1950. So you can see right here what I did is that I took a look at each year and I asked myself, how long has it been since 1950? So 10 years since 1950 gets me to the 1960. 1965 is 15 years since 1950, and we progress from there. So this is the data we want to use, and our independent variable is going to be years since 1950, T. And our dependent variable is going to be the S. The salmon population is dependent upon how many years it's been since 1950. Now it says, though, that we want to construct a scatter plot, but we want to do it on our calculator. So how do you construct a scatter plot on your calculator? Okay, so from your main screen on your calculator, what we're going to do is we're going to first go to this button right here called Stat. So I'm going to hit the Stat button, and you'll notice that I have options to go left and right to open up different menus. When you open it up, it's right on Edit, Edit, and that's exactly what I want. So I'm going to hit Enter, and you see essentially two columns. Well, this is where we're going to put our independent and dependent data. To clear out a column, go up and highlight the column heading L1. Do not hit Delete. Hit Clear and the down arrow. We go over, highlight L2, hit Clear and the down arrow. So in L1 now, what I can do is I can put my independent variable. L1 is going to be my independent, so that's the 10. Hit Enter. 15, Enter. 20, 25, 30, 35, and 40. Okay. L2 is where my dependent variable goes, so that's a 10.02, a 10, 7.61, 3.15, 4.59, 3.11, and 2.22. Good, so we've got our data in here. Now we want to tell the calculator to make a scatter plot of this. So to do that, what I'm going to do is I'm going to go to Stat Plot, but to get there I have to hit the second button and then Stat Plot. And I see Plot 1, Plot 2, Plot 3. I'm on highlighted 1. I'm going to hit Enter. So you can see that I can scroll back and forth and turn this plot on and off. I'm going to turn it on. I'm going to go down and I'm going to select type. What type of bar chart do I want? The first option is what I want, the scatter plot. And then down here you'll notice your X list. X, remember, is your dependent. For us that's time, which we put into L1. Y list, that's the dependent. For us that's S, we put that in L2. So everything is good there. If it's not there, I clear that out. What I can do is down here in the blue, I can hit out, it's already, alpha is already selected, L1 to get it back. Actually I need second, not alpha, L1. Oh, let me get back in there real quick. So good, the L1 is there, good. Okay, so L1 and L2, and I'm going to select plus signs to be my little markers. I'd hit Enter there. Now that I've turned this plot on and I've selected this first option right here, which is the scatter plot option, I've got a bunch of other options here, but I want that first one. Okay, I've got that selected. I'm going to now hit my graph button. So I hit my graph button. What you'll notice is nothing shows up. Well, the problem is that our graph is showing a wrong range of data. So what we're going to do is we're going to go to this button that says Window. Now, X is our independent variable, which is T. What I'm going to do is I'm going to switch the minimum value to 0. Then I notice that my data goes up to 40. So I'm going to set my maximum up to 50 so that I go a little bit above my data. So what that's going to do is that's going to show me just the part of the graph along the x, the independent variable, from 0 to 50, which fits all of this data right here. I'm then going to look at my y's, which is my dependent. I notice that I need y min, I better start at 0, but I go up to 10.02. So maybe I'll go up to 12, so we're a little above. The other values, don't worry about changing. So now I'm going to hit graph and look at what we have. We have that now to work with. Great. So let me do a snapshot of that really quick. Okay. And okay. Yeah. Here's the scatter plot. We can move on to the next questions now and answer questions about the scatter plots. Okay, so for instance, is the data approximately linearly related? Now, taking a look at what we've got here, are there a few points that are a little bit off? Yeah, but for the most part, does it look like I could draw a pretty decent straight line that goes through all the data? The answer is yes. So we would say yes, the data is approximately linear related. Now, this next question, though, is an important one. Will model breakdown ever occur with a linear model? If so, when and why? So if I look at this, if I drew a linear model down here, okay, if I drew a linear model, let me see if I can do something real quick. Okay, that looks like we're not going to be able to do that at the moment. But if I look at this model right here, the question is, will model breakdown ever occur? The answer is yes, and here's why. If I drew a straight line down through this, wouldn't there be a point at which I would get down to my x-axis, which in the y would be 0, and then the line would continue that pattern? So there would come a point at which it would actually start predicting negative values for the population of fish. Okay? Now, so will model breakdown ever occur? Yes. The model predicts negative values after around, well, it looks like from our data, if we follow this out, we know that 40 is here, so if I follow a model out, maybe around 45-ish is when we would hit that x-axis. So around 45, which for us, that's 1995. Values after the model predicts negative values after around 45. So what we can say is that yes, model breakdown has occurred because it's predicting something that's not physically possible. We can't have negative fish in the Pacific Northwest. More often than not, what happens is, as different species decline in population, at some point, what we know from reality will happen is it'll either level off, or it'll level off and then start going back up again. It's often cycles that we see in population of animals. Good, so there's how to construct a scatter plot on your calculator. There were two other questions that we didn't quite get to from the other problem that we looked at that I want to take a look at really quick. So in the problem related to the millions of visitors to the Grand Canyon, three questions that we left off on. Number one, will the linear model ever experience model breakdown? Okay. And I said most likely. Why? Because the Grand Canyon can only handle so many visitors. Right? You can't have 3 billion people visit the Grand Canyon. There's physically not enough room. So more than likely, it will most likely level off someday. Okay? Or start to decline depending on the situation. How about this question? What is the t-intercept and what does it represent? Well, the t-axis is the horizontal axis, so we look at where our model intersects the t-axis, and it looks like around negative 20. Well, the coordinate of that point is negative 20, comma, 0. And what does this represent? It represents the year in which there were no visitors. Well, no visitors to the Grand Canyon probably means model breakdown, because there's always been visitors to the Grand Canyon. And negative 20, when we're referencing from 1960, means 1940, 20 years before 1960. Now the last one here, what is the n-intercept and what does it represent? Well, our n-axis is the vertical axis. Okay. So I look at where our model intersects the vertical axis, and it looks like it's about 1.4-ish. So the coordinates of that point right there are 0, comma, 1.4. From my origin, I don't go anywhere left or right on the x-axis. I just go up 1.4. And what does this represent? It represents how many visitors you have in year 0, which for us is visitors in 1960. So it looks like there were 1.4 million visitors according to our model in 1960. So that finishes up what we missed and didn't quite get through on this last Saturday. So go ahead and give that a try, and good luck on the quizzes, and we'll see you in class on Saturday.